Okay, I'm gonna get going because, um, yeah. So, hi everyone. Sorry if you haven't met me before. I'm miyagod, um, the benevolent leader of Mia Maker. We're an open source software collective. Um, we have a Twitter. If you don't already follow us, called just Mia Maker, no spaces. Yeah, started as a token experiment, quickly grew into a developer and artist community. And yeah, this will be my third class teaching in um, the or not, the Milady bootcamp. The first one was really just an overview of myself, things that I've done on the blockchain. I showed some cool code when I still had it. Um, and then that one was not recorded. And then the second one was the first one that I recorded. Um, I have the original first recording on YouTube under Media Maker. Here you go. Yeah, so in this uh, video, I kind of introduced bonklers um, and the mechanism of how they work. Here. Oh no, never mind. I can't do it. But yeah, so how it's a reserve back NFT, and we're building a bot to compete for this first um, position on the auction whenever the current one is over. So just a refresher. Nope, it was this. So right now I'm just getting the request. I think it was C equals 1. If that doesn't work, we can just go to the bonker bot. Question mark. There we go. Or bonk. Here, I'll just do this. But yeah, so this is the API. Let's see, you can get it right here. That we were using to get all the information. Um, this auction data will hold everything about the current auction. Um, yeah, so what you can see here is we made a GET request to this API endpoint. We JSONed the data to make it readable. We figured out what time it was because that's going to come down a little bit later. But next, we grabbed this bonkler ID, the next bonkler ID, um, generation hash, next generation hash, end time. And this is actually the first data point that we'll be working with when we um, make some decisions around what to do, because basically this bot only works if this end time is in the past and at 0, which means that the auction has ended. So, um, I'm kind of old school, so what I like to do is start with the main function. I'll say if this, do something, right? And we're gonna call this function, I don't know, bonkle, not binkle, bonkle. All right, and then what we need to do is define bonkle. And we're just gonna say, hey, this is what it is right now. So just for example's sake, we're gonna run this real quick. And yeah, see, it's all I did was add this I don't know, it's some old school shit. I don't even know why I do it anymore. It's just the main function. It's like creating a main function. Um, so the first thing we're going to need to do is to check this end time and see um, basically what is the difference between now and the end time, because that's what we want to when. So we'll say if. Oh no, what was that one thing I did? It's like if check now, right? Then we'll move on, and then else. Uh, then we'll time dot sleep, and I think what we'll do is just do this. Um, we'll do, what do I want to name this? Let's call it T. So what? I'm just trying to. I'm like, sorry guys, I'm a little sick. But yeah, cool. Whoa, new people showing up. What's up, y'all? Um, so what I'm doing is trying to figure out the logic of how we want this to flow, right? So we want this bot to come in. We wanted to grab this end time. We want to see what the time is now. Um, and here, I think I did this. T equals a function. And then we did define get time. Right. So we'll just say so all we're doing is we're taking this little action and then return. What was it? End time minus now. End time minus now. Um, okay. So what this should do is get the time in seconds for how much longer until the um the auction is going to go for. So let's just see if this works. Cool. So there's 80,000 seconds left, which means, yeah, there's like, it just ended like 2 hours ago. Um, is there a way I can show you? Oh, look, 21E8 won this last one. Um, no, I don't think there is. I was going to try to show you, I don't know if there is a way to do. What I'm trying to find is the previous bid. Um, so this is 92, or no, 95. So yeah, what I'm trying to do is find a previous bid time timestamp. No. Yeah, okay. Well, it's not no big deal, but basically what I was trying to do is show you that um, this this amount right here. So let's look at end time. See how it's like 16,896,93,815. That doesn't change, right? Because that's like a set time in the future. So, all right, now this is tomorrow at 15:23 UTC. So, you can see that like this is the exact second, like we have the exact second that this thing will end. And the only way that this will kind of be topped up is if within the final 15 minutes, someone makes a higher bid, and then that resets to, I believe, like another 15-minute timer. Um, but anyways, so this logic is basically going in, grabbing the time that we want, comparing it to now, and then bringing it back. And I used to do, I think, something like this just to give it like a 1 second buffer, maybe. I forgot how I did that. But it's okay. We don't need to worry about that right now. So this is how T is going to be how much time we have left. And what we want is for T to be 0, right? So we want 0 or negative because that'll mean that this clock, this end time of the auction has gone to 0, or it's basically passed without any new auctions. So now that means the bonkler bidding is in a state where the next bid that comes in will create the new auction. So contract bonkler auction. I'm just trying to show you guys a transaction. If you check the previous video, I go through it, showing you there's the transaction that makes the new mint. Here, I'm just gonna find it again. At least try to. Yeah, so here, create bid. So yeah, this 8 ETH one that came through, right? It transferred the old bonkler to a new person, to the person who won. It transferred the ETH to the vault, and it minted the new bonkler, all in the same transaction. So this 8 ETH bid is should be here, Mr. Milady. 28. Oh, this is because I haven't refreshed it. There you go. That was from like a week ago when I did this, but yeah. See, so this guy JRW126, his bid failed. I don't know why it failed. It looked like it was in a previous block. Oh, there you go. Because Mr. Milady, this bid right here was in the same block, right? 147, 147. But he had a higher ETH value, and I imagine that Mr. Milady has a higher max priority, which is why JRW failed. So here, this is the Mr. Milady transaction. You can see max priority is 4.6. This is the JRW transaction, 0.1, bang. So you can see it all comes down to your positioning in the block, right? So the higher your max priority, the higher the position in the block you'll be. So, right, so this guy was in, Mr. Milady was in 31, JRW is in 123 because they didn't have a higher max priority. So what priority does is it moves you up the stack of transactions that are going to be ordered in the block. If this guy had a 4.7 max priority, he would be in a position before this guy. And so what that would do is it would create the conditions where the auction was still open. So when the auction's open, the bid is basically 0, right? So a 2 ETH bid is greater than 0, so this would have went through. But because this transaction got put on the blockchain first, that new bid was now 11, So when this transaction came through, 11 or 2 is less than 11, failed, bang. Um, but yeah, this is like, I think I described it last time. This is where we compete for this initial position. But yeah, glad I could show you and share it. So now what we're going to need to do is basically say, right, if t equals 0, what does that mean? That means that um, time, right, now is like, it's actually more than or equal to the actual end of the auction. So now that means we're going to want to bid. And the reason I have this is because basically it says this, because this is the difference between the time. If that, say, let's say the auction still has, 30 seconds left. Instead of running through this functionality, I'm going to wait 30 seconds and then double check that the time has been, um, you know, there hasn't been a new bid that's increased the end time, and then, just kind of go back through that process. And you sometimes see me doing a lot of my code is just do a while one loop. So it's gonna run this thing is gonna run, and then if it doesn't, if it doesn't reach the end time, if it's not the current time of that's the end. I feel like I'm sounding so confusing right now, but basically, if the auction's not over, it will sleep until the auction's supposed to be over, and then double check it again. Um, so that way you can leave this running. But the one thing that I've found is if you leave it running for over, like, I think like 5 or 4 minutes, sometimes it gets a little wonky. So it's best to run this function or the script when the bid is about to end, within, like, the first, like, when there's like 10 minutes left on this thing, right? So when it's like, hey, 0 days, 0 hours, and, like, 5 minutes, like, that's when you start want to, like, running the script to see, um, just to be ready to hit that next bid. So what we'll do is we'll do one more. Oh, whoops. I think what I did, yeah, because I'm working through all this logic all over again, guys. So bear with me, but I'm definitely going to change some stuff up, because I think what I want to do is just do one request and grab all this data. So instead of having this function, I know I just built it, but whatever. We're going to do this. Uh, so we're going to get some shit, and then we're going to get some more shit. And then time is just going to equal this. Okay. Because that way we're only making one request instead of having to make multiple requests. So we get our data, and time, if t, whatever. Okay, so if t, what do we want to do? Oh, geez. Um, pretty sure we need a check right here to see if the next generation hash does not equal the gen. I don't really remember this step, but basically, there's been edge cases where whoever was, Remilia basically didn't update the gen hash in time, so the next gen hash was actually the previous gen hash, and it would fail, make your transaction fail. So this check is to kind of double check that. But yeah, if that works, then what we'll do is, I think we're like almost ready to start bidding. um, yeah, so we're gonna also want to grab the amount equals underscore data amount just to see. So this will show us the current bid. So yeah, we're actually getting ready for Web3. So um, this is kind of good. I don't think I have pip3 install Web3. So Web3 is Web3 Python. This bad boy. It's how I get everything done. Um, yeah, so it's actually funny. I haven't used this in a minute, but this is how I generally send transactions, is with the raw send transaction. Um, we need to connect with the provider. I, I kind of want to learn how to use the IPC, which is like a local file system to connect, but because it's the fastest, most secure. But I guess we'll just do the general one because it's really easy. Async Web3 WebSocket. Hmm. Server asynchronously. Oh, I see why. So asynchronously means shit gets sent out. We don't really care if it comes back. Fuck, this kind of sucks. I wish I had my original. Um, all right, we're just gonna do this. Import doodle doo. We need to get RPC. So we need an RPC. Um, yeah. All right, I'm just gonna stop sharing my screen real quick so I can get the API from my other sheet. So give me 1 second. I probably have to cut this from the the video. But yeah, one thing you guys should know about me is I don't plan anything ahead. I just do it in the moment. Um, yeah, I actually here. It's actually not a big deal because there's a free one we can use. So here. But yeah, I never really plan anything out. I kind of just figure it out on the fly. I find that to be a little more fun. although it isn't always the easiest way. But I just found the free. So yeah, super simple. HTTPS dot what was it? ETH dot normalrpc.com. Okay. I'm doing Web3. Now I gotta remember how to use Web3. Um, choosing to connect, built-in contacts. No. Sending transaction. We don't need to set a transaction. What I want to do is get information about an address. Web3.eth, Web3 API. Yeah, so to text. Wait, I think I just saw something. So here, you can also just do like get nonce amount Web3 pi. Get trans ETH.get transaction count. That might be the way. So yeah, this is the way it used to be, HTTP provider. So they definitely upgraded some stuff. But here, I'm gonna take, because we're about halfway, I'm gonna take a minute. I gotta go grab my computer charger because my computer's getting low. But just give me 1 second. Also, because we're halfway, I gotta plug Mia Maker. For those of you who showed up a little late, I'm miyagod, the leader of Mia Maker, open source software collective. We build protocols, new standards of tokens. Um, we have our first project, Mia Mints, coming out, which redirects liquidity of NFT mints towards a certain collection's NFTX pools, as well as a few other features. Yeah, we're mostly a community full of artists, devs, pretty much just people who are working on cool stuff and want to meet other people working on cool stuff. So yeah, if you haven't already, please follow us on Twitter at MiaMaker, and then this will take you to our Discord, which will then allow you to engage with the people who are in here, right? Yeah, and you can see kind of stuff that we're working on. I definitely check out announcements to see like the timeline of like what's happened. Um, yeah, but other than that, let's get back to it. So where do we left off? All right, so we're connected to Web3 hopefully, and then what we're gonna do is we're gonna say Web3. We're gonna say nonce equals Web3 dot the ETH dot get block transaction count, get was get transaction count, but okay, we can just do get balance. I do want to get transaction count. Default one. Get balance, get block, get code, get uncle by block. I may be looking in the wrong place. Marketing activity, submit work, transaction. Alright, anyways, I'll just do this to show you guys how it works. We'll get balance, and we'll go for miyagod. Right, and then just for, let's delete that. I know, I kind of want to. I'll just go like this. So we'll just say val equals print val, and then we need to do this real quick. So yeah, this part, like I said, we already been through, but right here is kind of just what we're testing right now. So let's see what happens. Uh-oh. Oh, oh, I see why. What the hell's going on out there? Code team. Async valid was never awaited. Async Web3 provider. Well, like I said, we're figuring shit out live. I don't know. I don't really want to look up a block. We're just trying to find the nonce of and the balance of excuse me, of me, right? So we have a wallet. We want to get a balance. Yeah. Get balance account block identifier. I don't get why I keep going to a coroutine. It's never awaited. Web3.8 get block. Isn't this fun, guys? This is what it's all about. Just banging your head against the keyboard and just trying stuff. Get underscore block. Right? Latest. Let's see what happens here. So it's putting us into some sort of like continuous, just like asynchronous calling. I think it has something to do with the HTTP thing I set up. So here, let's try it like this, maybe. Although I'm not sure if it's gonna work. And then what do we have? We have this bad boy. All right, we're getting something, but it keeps feeding us um, the same thing over. Oh no, shit! I'm an idiot. There's a while one loop. I'm so I'm so sorry, everyone. Didn't mean to waste the last 5 minutes, but yeah, that'll cause a problem. Um, dope. Uh, yeah, I'm not always. Oh, not always on point, but okay. It's good to know that this worked. I wonder if I just deleted it, so it's not even up. It's not really that good, but all right. So we're getting this. Now, I imagine if we do this, it will work. Right. Bang! Look at all those Ethereums. Cool. So this is, um, yeah, this is it in the total amount, right? So Ethereum has like 18 decimal places. So really, it's, yeah. And then I think if I go divided by, let's say, ETH1, and we're gonna set an environment variable where ETH1 equals uh, a converter. It's like a tool, ETH unit converter. So one ether equals this many when, right? And then if we divide it by that, let's see if it works. Bang! See? Cool. Now we've got 29 ETH. miyagod has 29 ETH. So that is beautiful. Um, so what we need to do now is, like I said, I don't even know what I said. Probably did this a while back. But what we need to do is make sure the balance that we have in our wallet is over this amount, which it should be when the auction is starting over, because um, this will be zero. What else do we need? We need our balance. We need the knots. I think it's just a get transaction count. So here we're gonna say um, balance equals that. Knots equals 3.8 get. transaction count. And we'll do another. So one thing that we're supposed to do is I'll do later is set up, probably in the next class, I'll set up an environment variable um, file, and then we'll load in the environment variables. So that way you can, it's a little sketch, but you're gonna need to hold your private key in the environment variable and your address, and that way we can just load them in without having to like upload that to the actual GitHub or anything. But for now, oops, we'll say address equals miyagod. So then, oops, and then we're gonna do a little print statement to show that we got what we want. We're gonna say, I don't know, miyagod has bow ETH and mounts transactions exclamation point. So we run it. Miyagod has that ETH and 113 transactions. Cool. So if you go, just to double check, if you go to miyagod and check my latest nonce, 112. So this 113 is the nonce that we're going to add. This is the actual nonce value that we're going to add when we create our transaction. I'm going to jump ahead because we have like 15 minutes left, and I don't really feel like struggling to figure out this logic of how I want it to flow. I guess what we'll do is just say, hey, we'll imagine all of that logic's right here, and then we will, we can just start building our transaction that we want to send. All right. So what we're going to do, let me think. Yeah, we're just going to start building our transactions. So we're going to say txn equals this, right? And this is going to store all of the information on our transaction. So, for example, right, we don't really need from, but we need a to account, because what we'll be doing is we'll be actually be sending a transaction to this contract in order to create the bid, which is their proxy contract, I believe. Yep. So what we'll also do is copy, I'll say bonk bonk address, right? And then so we're gonna want to build a transaction that's going. I think you have to use some sort of syntax. Yeah, this key value pair thing that you have to do. Even though they're using a send transaction, we're going to use send raw transaction, so it'll be a little different. But yeah, so we want to go to bonk address. We want to go to the bonk address. I think we got to sell. Here we got nonce. We're just going to equal this nonce. we're gonna need value. So this value is actually gonna be it's gonna be we'll just put ETH1 just for simplicity's sake. But this value is actually the bid that you are bidding. This is the amount that you're bidding, right? Um, Data. We want to get data too, right? Yeah, we need these three. And there's a few APIs you can use to get this. But I'll just worry about that, like I said, next time. Whoops. Sorry, I'm just like a little, so I like if I'm gonna use double quotes, I'm gonna use them all everywhere. All right, so yeah, these are probably in way. Yeah, right, one way. Which, and if you remember, like, right, we were competing on, remember these two guys, Mr. Milady, JRW. So we're competing on a max priority level and a max. Yeah, so we don't want to have just one GUI for max priority. So we'll put, I don't know, 10. So, or we'll put 100. I don't know. What did that one guy put? He put like 4 or 5. So here, a good way to double check actually is just to go here, go to the previous persons. So yeah, he had 4.6. The previous day winner had 20. Previous day winner had, hold on. Nice dub. And it was a .9. Nice. Way to scalp that, bro. Let's see. People haven't even been competing. Fuck, man. All right. Which is funny because I hit this one. Yeah, I hit this one because I thought the double Sonora with the gun. I mean, how could you not? But then I hit it. Maybe I'm a little, yeah, see, and then next day, 20. People be competing with me. It's funny. Um, all right, so we've got our gas. I mean, this isn't solved yet, but we can come back to it. Um, but what we need is our data. We need to create some data. So if you can see here, right, not ETF. So this right here is the actual data that is telling the EVM what to do, right? So if you remember, let's see, if you remember here at the contract, at the bonkler auction, where's the create bid? Right here. So this function actually, takes two inputs, bonkler ID and the generation hash. And if you see, this is the generation hash that's been put into hex bytes. Excuse me. And this is the bonkler ID that's been put into hex bytes, right? And they're padded, I think, with like 36. I don't remember the number. But yeah, so this is the first input. This is the second input. And this right here is the function identifier. So, 1, 2, 3, 4, 5, 6, 7, 8. These first 8 bytes actually tell the EVM which function is going to be called on the contract, right? So this contract right here, if you actually go to write contract, you can see, boom, you see how this has this 0xb7751 C17 B775 blah, 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 C17. So because that matches up, the EVM knows that, hey, this incoming transaction is going to call this function right here. And like I said in the previous one, this is actually the message.value, and then these are the two data inputs. Um, but yeah, I'm trying to think of what else I want to do before the time ends. But yeah, we'll say data, right? Because you need a data field, right? And what is this data going to be, right? We like basically what we want to do is take this information that we're pulling from the API and then create hex data out of it and put it together and basically build this right here that holds, the proper bonkler ID that we want and the proper generation hash. So what I'm gonna do is there's this really cool. I'm kind of pissed I missed out. I guess I'm not gonna go into it now, but there's this function called zfill that allows you to like pad zeros to a certain amount, and then create a hex like code off of anything. So let's just say like hex to decimal 95, right? And if you look, oh shit, 95. Wow. Isn't that wild, guys? Isn't that so cool when things add up like that? And then if we go here, you can see, actually, I don't know if that's going to be the right thing. Let's see though. Insomnia. Oh, look, it is. Bang. So yeah. So this 78677, this is our generation hash. You can see, look, it's right here. Same generation hash, same number. And this is it in Hexify. So what we need to do is in this script, have a little functionality that takes this decimal and puts it into hex and takes the previous 5F, I think it was, the bonkler ID and takes it from decimal value to hex value. And we'll do that next time. We'll do so things to do next time for myself. We'll definitely need to handle the gas situation, and I'll be able to talk more about how to compete on that. Even though I've talked about it kind of extensively already. We'll build the data. So we'll actually go in and take the generation hash and the bonkler ID, and we will hexify that and pad it and make it look good with the right function identifier. So that way, when we send it through, the EVM will know exactly what to do. And then yeah, we just have to fix up some of the logic in terms of like I gotta like kind of remember how we want things to move. We'll also add in an environment variable so that way we can have loaded in like our private key, because then once we have our private key loaded in, we can sign the transaction and then actually send it, which you can see happening right here on this thing. But yeah, I'm gonna, I guess, shut her down for now. It kind of sucks. I really want to finish this bot. But I also think that, working through it with you guys is pretty beneficial. Gives you guys kind of like a good understanding of what it's like to kind of work through this stuff. And if you guys are also like working on anything of your own, feel free to reach out to me and ask for help. The Mia Maker community is very accepting and we love new ideas. So even if you're not a dev or an artist, if you have an idea that you like want to think out with some people, like we're always open. We have some open forums whenever you see events, so please feel free to hop in. But yeah, I'm gonna keep recording this time, and I'm gonna hop in the lounge so that way we can have like an open Q&A. But just FYI, because last time I did that, I stopped recording and there was actually some really good conversation. So I want to keep that in the video. So yeah, so I'm gonna hop out and into the lounge real soon, or like right now, and then you can ask me any questions there. All right. Thanks for coming, guys. I really appreciate it. I don't know if anybody's gonna come ask me questions. Obviously gonna have to cut this.